Just like with triangles, four-sided shapes or really any sided shapes, 5, 6, 8, 10, 12, whatever, they can have similar figures. And for triangles, it was a little bit easier to know when two triangles are similar because they had to have the same angles on the inside. For these, you have to specify that these two shapes are similar. We're assuming that these two rectangles are similar, so we're going to be able to write a proportion for this, right? If this side goes to this side, that means this side goes to this side. You can also write a proportion that goes from like this one to this one and this one to this one. Either way works. For the first case, where this side goes to this side, we can do 1 3/4 goes to 3 yards. This is inches to yards. Equals 1 1/4 inches to x yards. You can see that I have yards on the bottom and inches on top. You can also flip it around to be where we have 1 3/4 inches to 1 1/4 inches equals 1 3/4 was this side. So we have 3/4 or 3 yards on the same side as that. 3 yards to x yards. So this side and this side are on the bottom. This side and this side are on the top. So similar thing, right? If you cross multiply either one of these things, you can see we always have 1 3/4 times x, 1 3/4 times x, and 3 yards times 1 1/4. 3 yards times 1 1/4. So either way you do it, you're going to get the same answer. Okay, so what does that give us? Let me just give me some room here. This is going to give us 1 3/4 times x equals, see, this is going to be 3 times 1 1/4. This is probably going to be easier with decimals. 1 3/4 is the same thing as 1.75. It's going to be 1.25. And so 3 times that is going to be 3.75. Now all I have to do is divide by the number in front of x. So I'm going to divide by 1.75. I get x equal to 3.75 divided by 1.75. And I get x is, I'm going to have to approximate here, 2.14 yards, rounded to 2 places. That makes sense, right? This side was the bigger one, this side was the smaller one, this side was bigger, and x is a little bit smaller than that. Okay, here we're saying that these two parallelograms are similar. So once again, we can do this however way we want. Since we did this way for this proportion, let's do the other way. Let's do this goes to there. So 32.25 centimeters goes to x centimeters. And here we have these ones, right? This and this side are going to be similar to each other. And these two sides are going to be similar to each other. So we're going to go, these two are the bottom sides. So they're going to be on the same side of the proportion. And these two are the same side here, the sides. And they're going to be 241.40. And these are both in meters. So you can see that I have the centimeters lined up, meters lined up. Here I had the inches lined up this way, yards, or I had the inches lined up the other way. Either way you do it, you're going to get the same answer. Okay, cross multiply and divide. We're going to get 109.65x equals, we're going to get 32.25 times 241.4. 7785.15, and now I can divide by the 109. Okay, and that gives me x equal to 71. And that's going to be in centimeters since that's the unit of measurement we have there. Okay, suppose you wanted to print a display of this trapezoid around the Ulysses S. Grant Memorial, the Reflecting Pool, and Union Square. we want to make it a smaller rectangle so that the display can be something that we can actually do, right? This is a large amount of feet, so that there's no way we can put that on some kind of display. Okay, what's the scaling factor of the image, and what is the perimeter of the scaled down trapezoid? So we already found the perimeter previously for this one. The perimeter for this one is going to be, we need to scale it down first. So what's the scaling image, or what's the scaling factor? So we're going to scale it down by what? So this becomes 2.5. We can use the scaling factor by doing it like this. 2.5 divided by 607.78. And that's going to give us a 0.004113. It's going to be 0.4113% of the original, of the real distance. So it's this is a weird percentage because we're setting the smaller distance, but all we have to do is just take 0.4113% of each side, and that's going to give us the side lengths here. And if we add them all up, that's going to give us the perimeter of the scaled down image. So what is these two sides are the same, so I just need to do it once there. 0.4113% of that is going to be the percentage of 868.19 is what part? I'm getting 3.57 approximately for that. Those two side lengths actually. It's going to be this one and this one here. Okay. The same idea for this third side length. The percentage of the original amount is going to give us the new amount. And I'm getting 4.90 for that side length there. Okay, so this is the scale factor, right? Out of this number, or the percentage. And what is the perimeter? That's just going to be 4.90 inches plus 3.57 inches. There's two of them though, so we're going to multiply that by 2. And then plus this 2.5 inches, that was the fourth side there. And that gives us a total perimeter of 14.54 inches.